Hello grade 11. This week, we will discover why Earth is the only planet known to sustain life in our solar system. Our discussion will focus on the following learning competencies. 1. Recognize the uniqueness of the Earth being the only planet in the solar system with properties necessary to support life. And 2. Explain that Earth consists of 4 subsystems across whose boundaries matter and energy flow. Now, let's start our discussion with Lesson 1, the Solar System. Let's watch this video.
The solar system is located in the Milky Way's Orion star cluster. Only 15% of stars in the galaxy host planetary systems, and one of those stars is our own Sun. Revolving around the Sun are 8 planets. The planets are divided into 2 categories based on their composition: terrestrial and Jovian. Terrestrial planets, including Mercury, Venus, Earth, and Mars, are primarily made of rocky material. Their surfaces are solid, they don't have ring systems, they have very few or no moons, and they are relatively small. The smallest and closest to the Sun is Mercury, which has the shortest orbit in the solar system at about 3 Earth months. Venus is the hottest planet, with temperatures of up to 867 degrees Fahrenheit due to an atmosphere of carbon dioxide and extensive lava flows. Next to this world of fire is a world of water, Earth. The water systems on this planet help create the only known environment in the universe capable of sustaining life. The last of the terrestrial planets, Mars, might have also supported life about 3.7 billion years ago, when the planet had a watery surface and moist atmosphere. Beyond the 4 terrestrial planets of the inner solar system lie the Jovian planets of the outer solar system. The Jovian planets include gas giants Jupiter and Saturn and ice giants Uranus and Neptune. The gas giants are predominantly made of helium and hydrogen, and the ice giants also contain rock, ice, and a liquid mixture of water, methane, and ammonia. All 4 Jovian planets have multiple moons, sport ring systems, have no solid surface, and are immense. The largest Jovian is also the largest planet in the solar system, Jupiter. Nearby is Saturn, the solar system's 2nd largest planet. Its signature rings are wide enough to fit between Earth and the Moon, but are barely a kilometer thick. Past Saturn are the ice giants Uranus and Neptune. The slightly bigger of these ice giants, Uranus, is famous for rotating on its side. Next to Uranus is Neptune, the outermost planet in the solar system and also one of the coldest. Orbiting the terrestrial planets is the asteroid belt, a flat disk of rocky objects full of remnants from the solar system's formation, from microscopic dust particles to the largest known object, the dwarf planet Ceres. Another disk of space debris lies much further out and orbits the Jovian planets, the icy Kuiper Belt. Apart from asteroids, the Kuiper Belt is also home to dwarf planets such as Pluto and is the birthplace of many comets. Beyond the Kuiper Belt is the Oort cloud, a vast spherical collection of icy debris. It is considered the edge of the solar system since that is where the gravitational and physical influences of the Sun end.
Now let's check your understanding by doing this simple exercise. Direction: answer the 3 questions that follow. Think fast. Number 1. What is the closest planet from the Sun? Answer. There you have it. Number 2. What is the farthest planet from the Sun? Answer. That's correct. And number 3. What is the largest planet in the solar system? Answer. Very good. And that's it. Congratulations in finishing lesson 1. Now let's discuss lesson 2, dwarf planets. Let's watch this video.
As more and more objects were discovered near Pluto that were close to Pluto in size, astronomers realized that they couldn't all be planets. Something had to be done. In 2006, the International Astronomical Union created a new category, dwarf planets. For an object to qualify as a dwarf planet, it only had to meet 2 criteria. 1, it must orbit around the Sun. 2, it must be massive enough for its own gravity to pull it into a spherical or mostly spherical shape. Planets had a third qualification they had to meet. They must have cleared their orbits of other objects. Since dwarf planets often share their orbits with asteroids, comets, debris, and even other dwarf planets, this third point made it easier to tell the difference between a planet and a dwarf planet. There are currently 5 officially recognized dwarf planets in the solar system: Ceres, Pluto, Eris, Haumea, and Makemake. Astronomers believe that there are hundreds of objects in the solar system that are likely to be dwarf planets. As scientists continue to study them, it is likely that more and more will be added to our list. Until then, I hope you enjoyed learning about Ceres, Pluto, Eris, Haumea, and Makemake, the dwarf planets of the solar system.
Test yourself again. Let's do this simple exercise. For this exercise, simply name the 5 known dwarf planets in our solar system. That's correct. The 5 dwarf planets are Ceres, Pluto, Eris, Haumea, and Makemake. Very good. And that's it. Congratulations in finishing lesson 2. Now let's discuss lesson 3, the planet Earth. Watch this video.
Earth, the only planet known to maintain life, a product of scientific phenomena and sheer chance. This blue speck in space holds the past, present, and future of our very existence. Approximately 4.5 billion years ago, the Earth formed from particles left over from the creation of our Sun. Gravity drew these particles together to form pebbles, which then formed boulders and eventually the Earth. At its heart is a solid inner core covered by a liquid outer core. Above this sits the mantle made of flowing silicate rocks and a rocky crust. This rocky mass is the 3rd planet from the Sun, orbiting the star from an average distance of about 93 million miles. It's close enough to the Sun to be warm, unlike the cold gas giants, but not so close that its surface is exposed to extreme heat and solar radiation, as is the case with Mercury. Earth's unique position in the solar system allows it to house phenomena yet to be found anywhere else in the universe, particularly liquid surface water and life. According to one theory, much of Earth's water is as old as its rocks, both of which having formed during the Earth's earliest days. Because of Earth's unique distance from the Sun, the planet is able to contain water in all of its forms, liquid, ice, and gas, rather than have them permanently frozen or evaporated into space. But Earth is the only known place in the universe with liquid water on the surface, thereby having unique cascading effects on the planet. It hydrates the land, helping create nutrient-rich soil. It collects and pools to form oceans and freshwater systems. And it cycles upward to add moisture to Earth's protective atmosphere. And where there is liquid water, there is life. About 3.8 billion years ago in Earth's oceans, primitive life existed in the form of microbial organisms. They, in the ensuing billions of years, gave rise to a range of more advanced life forms that thrived in Earth's seas, lands, and skies. As the only world known to harbor life, Earth's biodiversity is expansive in nature. An estimated 1.5 million species of plants, animals, bacteria, fungi, and others have been cataloged, with potentially millions, if not billions more, yet to be discovered. Home to life and fueled by water, Earth houses a unique global ecosystem, as curious and as grand as the astronomical events that made them possible.
Now let's check your understanding by doing this simple exercise. Direction. Based from the video, give at least 3 reasons why Earth is the only planet known to sustain life in our solar system. Very good. Answers are Earth's position in the solar system, presence of water, and presence of atmosphere. And that's the end of Lesson 3. Congratulations! Now let's discuss Lesson 4, Earth Systems. Let's watch this video.
Earth's interconnected cycles. Air, land, water, and life are all interconnected. The different systems of Earth are known as the atmosphere, lithosphere, hydrosphere, and biosphere. These systems work together to create our world. In order to understand the relationship between these systems, we need to understand that each system is a group of related elements that form a complex whole. Take a breath. You are breathing in air from our atmosphere. The atmosphere, from the Greek word atmos, meaning vapor, is a thin layer of gases surrounding the planet. The atmosphere serves many functions. It offers protection from UV radiation, helps hold in heat to warm the planet's surface, and contains the oxygen and carbon dioxide required for animal and plant life. Earth's atmosphere comprises 78% of nitrogen, 20.95% of oxygen, 0.93% of argon, and 0.039% of carbon dioxide and other gases. The hydrosphere, from the Greek word hydro, meaning water, includes all of the water covering Earth, both in liquid and solid form. 71% of Earth is covered in water. From the depths of the ocean to the ice-capped peaks of the mountains, the hydrosphere is all around us. Our biosphere, bio meaning life, contains all of the life on Earth. Living beings are found everywhere on Earth, even on the parts that appear to be uninhabited. The biosphere overlaps the atmosphere, lithosphere, and hydrosphere. We are part of the biosphere, as are the crops that we grow and the pets that we keep. Every living being, from tiny bacteria to blue whales, is part of Earth's biosphere. Earth's crust and upper part of the mantle make up the lithosphere, which is from the Greek word for stone, lithos. Our lithosphere consists of approximately the first 60 miles of solid material from the surface of the planet down. This is also referred to as Earth's crust. The lithosphere constantly changes because of shifts in the tectonic plates. This movement is very slow, and we do not feel the change unless an earthquake or volcano occurs. A volcanic eruption affects all of Earth's spheres. The magma coming up through the Earth is part of the lithosphere. The gases and materials from the eruption move from the lithosphere into the atmosphere. The lava pouring down the volcano will change the biosphere, while the condensation of water alters the hydrosphere. These systems all interact to create and maintain the world as we know it. Human beings from the biosphere walk on the ground, the lithosphere, breathe the air, the atmosphere, and drink the water, the hydrosphere. We could not exist without any one of these systems.
And that's all for this week. Watch out for next week's video. Congratulations!